to minimize confusion, because a lot of you are trying to answer 2 questions at once. Do not answer 2 questions at once. Just focus on one task, right? Move forward from there, finish that task, and then like segment and then move on. That will minimize the amount of like, wait, what am I trying to work out? Which gradient is up, concavity down? I'm so confused, right? So, I have the first derivative. I'm just going to focus on the second derivative. That's the first thing I'm going to do. You can see, to go from first derivative to second derivative, I have noticed, here are the spots where the first derivative has turning points. Do you notice that, right? So if I ignored for a fact the second that this was the first derivative and this was the second derivative, if I just said there's a function, differentiate please, you would say stationary point, stationary point. The derivative should be 0 and 0. Are you content with that? Okay. And the same way, to work out the rest of the picture, I would say, now tell me, is this the increasing or decreasing? It's decreasing here, it's going down, then it hits a stationary point, it goes up, and then it goes down again, right? So these signs in here, the signs on one graph tell you about the regions on the next one below, okay? So I've got negative down here, positive here, negative here. Are you content with that? So you can see I've got my parabola shape coming through here. I'm going to be a little rough, and there's my parabola. Okay. All right, now I'm ready to climb up the ladder. I've gone down. That will inform me when I'm trying to work out concavity. Let's go up. Okay. Now you remember, to go downwards, I said, tell me where these stationary points are. They're going to be zeros. So to go in reverse, I say, tell me where these zeros are. Can you see where I'm pointing? These zeros tell me about these stationary points. So therefore, to climb up the ladder, I say, tell me about these zeros. There they are. There are only 2 of them. Where you see those zeros, there will be stationary points up here. Okay? So there's one. I already drew a line through it because it was going down as well. But here's another one. I haven't done this one. So this line goes up. I don't need it to go down. I've already drawn the second derivative. Okay? So up here, these 2 vertical lines should be stationary points. Now the question is, what kinds of stationary points will they be? Okay? Now, for reasons that will become clear in a second, I'm going to do this right-hand side first. Okay? The derivative, in fact, I'm even going to write this just like I wrote it before. The derivative is 0 here. What do I know about the kind of stationary point that's here, and how do I know it? Any takers? It turns. The reason I know it turns is because the second derivative is, it's not 0, it's negative, right? Not only do I know it turns, I know which way it turns. The second derivative is 0, the concavity is concave down, so there's going to be a maximum up here. Is that okay? So I'm going to draw myself a nice high-ish stationary point, because I've got to climb up to there. Okay? Now, I look at the next part, and I say, ooh, look, I've got a 0 here, that's a stationary point up here, and then I say, well, what kind of stationary point do I have? So I look to the second derivative, and the second derivative is 0. Go back to your flowchart. That's not very useful in itself, right? I need to know not just that it's 0, because sometimes you can have a first derivative being 0, and a second derivative being 0, and in the case of y equals x to the 4, that's, well, it's a turning point, just like this was, okay? So what do I get out of this second derivative to tell me what kind of stationary point I've got? Yeah.
It's a point of inflection as well.
Yep.
And it's also a stationary point. There's only a set of points, 2 points that can actually fit that criteria.
Very good. So you can see, I've got the stationary point. The reason I know it's a point of inflection is not because of the second derivative being 0. Tell me, what's the definition of a point of inflection? A change in concavity. And look, it changes. You see, I went from negative to positive, concave down to concave up. I've got a point of inflection. It's stationary as well. It's a horizontal point of inflection. Okay. So I'm going to draw my horizontal point of inflection here. Okay. Remembering that I just said it's concave down to concave up. Concave down to concave up. I know it's going to be concave down like that and concave up like that. You see that? And what I know about the first derivative confirms that. Because look, the sign here, the first derivative is positive. That's why it's increasing up here. And then the first derivative is still positive. Look, it's still climbing. Increasing, increasing. You see it? Okay, now I'm ready to draw. There's the left-hand part. To join these parts, I'm going to be a little bit messy, but we'll try. Like that. Okay. You'll notice as well, I have my point of inflection there, which I got from here, where this second derivative also changes sign. And then up here, it goes back down. So some of you notice it's kind of like a camel, right? We call it the camel graph, right? Let's just confirm that everything is right. Let's imagine this was the question, and I've got to think about gradient and concavity. Tell me, increasing or decreasing? Increasing, increasing, increasing. What happens? It stops for a second, and then it just keeps on increasing. Then it stops, and then it turns, so it's decreasing. Do those signs match the regions here?
Yes.
They do, don't they? Look, positive, 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 positive. There it is. And negative down here. It works. Let's quickly do concavity. Concave up or down? Down, down, down. Transitions. Up, 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 up. Transitions one more time. Down, 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 down. And you can see, it works, right? Concave down, the second derivative is negative. Concave up, the second derivative is positive. And it resumes being concave down for the rest of its domain. It works. Happy? Okay, last one. Now, rather than leave you to your own devices on this, I will help you through. Okay, I'll help you through. It's not as hard as it looks. So, advice. Remember, one problem at a time. One problem at a time. So I'm going to go from this graph down to the bottom. Okay, I'm going to work out the second derivative. Okay. Now, this is a bit tricky. The first thing I usually look for when I'm going down, when I'm differentiating, what's the most important feature that you usually look for? You look for stationary points. Stationary points here give me zeros here. Right? Sorry, my finger's not there. And I've got to say that really importantly because people are confused. They think, oh, zeros here give me zeros here, stationary points there. You're climbing the wrong way. I'm differentiating going down. So I'm looking for stationary points. Tell me how many stationary points this has. None.
None.
It has none. That's what I meant to say. There's no stationary points. Now hold on a second. Hold on. Black pen in hand. Okay. This thing never turns. Its gradient never turns around. It never stops either. Is this left side over here, is it increasing or decreasing?
Increasing.
It's increasing. Which tells me the region down here will be positive. What about this guy? Is this increasing or decreasing?
Increasing.
It's also increasing. So you can see the regions when I differentiate down here, everything is going to be up here. You right with that?